Okay, so question 8. Here are the fourth and fifth terms of a Fibonacci type sequence. Each term is the sum of the previous two terms. So what that means is, when I add these two numbers together, so when I add that number that I don't know and 28, the answer's got to be 43. So what I can do is I can do 43 and take off 28 and it'll tell me what the missing number is. So I know that third number is 15. So I'll write that in there, 15. I need to keep working, so what I'll do is get a different colour. So what I know is these two, the two before 28, when I add them together, I've got to give me 28. So when I do 28 and I take off 15, it'll tell me what the second term is. So 28, take away 15, gives me 13. So I know that number there is 13. And the last one then, so what I know is I know that these first two, when I add them together, give me the third number. So when I add together something and 13 give me 15, so clearly you can see it's 2, but I'll just show it because it does say, show that, so 15, take away 13, gives me 2. There we go, job done. Now for the second part, down here, we've got, here are the first and third terms of a different Fibonacci type sequence. So we've got an algebra question, very similar to the one above basically, then haven't we? Work out an expression in terms of A and B for the fifth term. So I only need this last one, but obviously I'm going to have to work out the others to get there. Now what I know is that these two, just here, when I add them together, it's got to equal B. Now I'll call this one N, because I don't know what it is. So A add N equals B. So what I know then is I know that N is B take away A. So this second term just here, I know that it's B take away A. Now just be careful here, don't start bringing in loads of different letters. I know I just have, that's just for me explaining really. The next part, we shouldn't need any other letters. So to work out the fourth term, so to work out this one just here, I know that when I add the two previous terms, so when I add B minus A and B, it'll give me the fourth term. So B add B gives me 2B, and then I've also got a minus A here. Okay, so I know this fourth one here is 2B minus A. So now I'm ready to figure out that last term, that fifth term here. So I know for that last term that these two added together give me the fifth term. So I need to show that B add 2B minus A. I need to work that out. So B add 2B gives me 3B minus A, and that's the answer. That is an expression for the fifth term, for that one, in terms of A and B. So it's only got A's and B's in. So that's question 8, isn't it? Okay, right, next one. So we have Noah, and he's attempting to work out the base of different right angle triangles, like you do. And so here we have a Pythagoras question. Now, how do we know Pythagoras? I know it's Pythagoras because it's a right angle triangle. And we're finding a missing length. There's no angles or anything, so I know it's not trigonometry. Well, there's a 90-degree angle, but there's no other angles. So no, it's Pythagoras. So we know that a squared plus b squared equals c squared. So this is his working. He's shown some working for when y is 10 and x is 6. So value of y squared is 100. Yep. Value of x squared is 36. He's subtracting the squares because he's finding a shorter side. We know that this side is the hypotenuse, it's opposite the right angle, so we know y is the longest side. And then he's square root the answer, and he's saying the base is a square root of 64. Okay, so let's have a look at what we're being asked to do. So tick the correct statement. The method will always give an answer which is a whole number. Now we know that's not true. In class we've seen, it can be decimals. The method will sometimes give an answer to a whole number. And now that's the box we should tick. We know, for example, Noah's the answer, the base, is a whole number. We know the square root of 64 is 8. So there's some working to support what I've just ticked. Not enough. I mean, it is 3 marks. I've ticked a box, which is correct. I've given a bit more working, which is maybe another mark, but I need to do something else. The method will never give an answer which is a whole number. Again, we know that's not true. So let's give an example where it doesn't give a whole number answer. So what I've got to do is I've got to think of some numbers that x and y can be, that when I square them and subtract them, it won't give me a nice whole number. So let's think of some numbers. Nice easy ones. You haven't got a calculator. So let's see, I did y equals 3. And let's say x equals 2. So 3 squared is 9. 2 squared is 4. When I take away the squares, when I take away 9 and 4, I'm left with 5. And when I square root 5, it does not equal a whole number. 5 is not a square root number. When you square root it, you get something that's approximately 2, but it isn't 2. So that is an example that shows you that the method can give you lengths that are not whole numbers.